So we focused on triangles yesterday. Let's talk about all the different types of polygons today. Your target is going to be that you will be able to classify polygons and find missing angles in those polygons by the end of the section. Copy down your target, and let's define what a polygon is first. A polygon is a closed plane figure formed by 3 or more segments, and it is named by the number of sides. So it must be closed. If you have an open figure, it would not be a polygon. Something like this would not be a polygon. But as soon as I close it off, if it's formed by segments, which must be straight, and 3 or more of them, then it is a polygon. You can't form a polygon by just 2 segments, because there'd be no way to close it. If you did close it, it would only be a line. And you can't, again, have anything that's curved. The segments must be straight. So something like this would not be considered a polygon. So these top 2 examples are not polygons. And this bottom example is a polygon. A regular polygon, then, is where all sides are congruent and all angles are congruent. So you could have a regular triangle. A triangle is a polygon. And we talked about these types yesterday, where the sides could be equal and the angles could be congruent. The sides could be congruent and the angles could be congruent, and that would be an acute equilateral triangle. So that's just one type of regular polygon. We're going to see some other regular ones today. Fill in these missing words, and then let's move on. Well, we want to come up with a way to see how many degrees are in a polygon. We know how many degrees are in a triangle, right? We talked about that yesterday. There was 180 degrees. And the reason there was is because when you take the vertices off and you put them in a line, these 3 will form a line, which means they have 180 degrees. So for a 3-sided figure, that is one triangle, you have 180 degrees. Well, a quadrilateral can be broken up. A quadrilateral has 4 sides, but it can be broken up by drawing a segment into 2 triangles. So if each one of these triangles has 180 degrees, then altogether a quadrilateral has 360 degrees. Let's keep going with this pattern. Pick one vertex to draw from on your polygon and break it up into the minimum number of triangles you would need for that figure. On a pentagon has 5 sides. They start from this vertex, and if we draw a diagonal to any non-adjacent vertex. I can't draw any more triangles there without overlapping them. This is the minimum number of triangles. There's 3. And since there's 180 degrees in each triangle, how many degrees will be in a whole pentagon? 540. And these values, guys, these sums, the sum of the degrees, it's going to be true for all pentagons and for all quadrilaterals. You can always use it whether it's regular or not. The sum of the polygon angles will always be that number. Continue on. Pause the video, finish the table, try to write a generalized rule down at the bottom for an n-sided figure. Once you fill in the rest of these numbers, you might see a pattern. So pause it, try it, then press play to go over it. So now that you've filled in the table, you can see that a hexagon has 720 degrees, heptagon has 900 degrees, octagon has 1080 degrees, a nonagon has 1260, and a decagon has 1440 degrees. You notice, hopefully you notice a pattern. The number of sides continues to increase, and how does the number of triangles relate to the number of sides? Well, this number right here is always 2 less than the number of sides. So down at the bottom, your generalized rule, if you have n sides, you're going to have n minus 2 triangles. We always had 2 less triangles than the number of sides, and for each triangle you have 180 degrees. So you're going to take the number of triangles you would have in that figure and multiply it by 180 degrees. That's your rule. So now if you had a 20-sided figure, you would know a 20-sided figure would be n, the number of triangles I would have would always be 2 less than that, so it would be 20 minus 2. And you could do 18 times 180 to figure out the sum of all the angles in a 20-sided polygon. Let's keep going with this then. Let's put this into action now. In your first example, what is the sum of the angle measures for this polygon? And then, what are the measures of each missing angle? So we did problems like finding the missing angles yesterday with triangles. Now we can do it with other polygons. The first step, though, is going to be to find the sum. How do we find the sum? The sum is always 180 times n minus 2, n being the number of sides. So for this problem, I have 1, 2, 3, 4. It's a quadrilateral. 4 minus 2 is going to give me 180 times 2, which is 360. Now you can take that sum and you can add up the angle measures and set it equal to that. So we're going to have 60 plus 100 plus 3m plus m equals 360. Now this is an equation you know how to solve. Combine your like terms. You can solve ahead of me too, please. So then what would you do to get m by itself? We always undo addition and subtraction first. (200 divided by 4 is going to be 50. So m has the value of 50, but that's not all I was asked for. Make sure you read the question carefully and solve what it asks you to find. It asked me to find the measure of each missing angle, so I actually need to find these. Well, 3m is going to be 3 times 50, which is going to be 150. And m is just 50. These two numbers are what I was actually asked to find, so those are my solutions along with the sum, which was 360. Remember, your angle measures are always in degrees. So again, the sum works for any polygon, whether it's regular or not regular. You just have to find the sum by using 180 times n minus 2. Look at example 2. Example 2 focuses on regular polygons only. Name each regular polygon and then find the value of x in each. So this first regular polygon is 6 sides. It would be a hexagon. And now we want to find the measure of the angle. Well, since it's regular, you know that all of these angles are congruent. So we could write an equation saying that 1, 2, 3, 4, 5, 6 x's is equal to the sum. But what is the sum for a hexagon? We can't just say it's 180, that's only for a triangle. You always have to find the sum. Now you have all the sums written on the first page of your notes, but let's say you didn't have those page notes. How could you find the sum? The sum would be equal to 180 times n minus 2. In this case, your n is 6. So your sum is going to be 180 times 4. 180 times 4 is going to be 720. Now you can take that and plug it into your equation over here. Since you have 6 angles with a measure of x, 6x equals 720. Now you just divide on both sides, and what do you find for x? X here is 120 degrees. Let's look at the next one. B is also a regular polygon, which means even though I don't see this in every angle, since it's regular, every angle is the same. Every angle is 10x plus 8. Make sure you recognize that. What would be the sum for this polygon? Well, this polygon has 1, 2, 3, 4, 5 sides, so it is a pentagon. And we know we're going to do 180 times 5 minus 2. So the sum here is 540. Now, this equation is going to look a little different, but you have 5 angles all at 10x plus 8. So you have 5 10x's plus 8. Make sure you could write out 10x plus 8 5 times, but that would take a lot of time. So if you're going to write 5 times that value, make sure you use parentheses. It's 5 times that whole angle. Now, how do we solve this equation? Well, when you have parentheses and they're locking in your variable, this is what I want to solve for, do something to get rid of the parentheses. The only reason those parentheses are there is because of this 5, so if we distribute the 5, we can drop the parentheses. And the parentheses are like prison bars, so we can drop them and then we can get x out. So let's distribute. We would have 5 times 10x, or 50x, plus, what's 5 times 8? 40. Remember, you only distribute multiplication, but when there's no operation seen here, we know it means multiply. And now this equation looks fine. We know how to solve this. So those equation skills that you have, those are so useful. You will always be solving equations. You will be using those in geometry and algebra 2 and algebra next year. Know your steps for solving an equation. So here I got x by itself, and x is equal to 10. Was I asked to find the angle measure here or just the value of x? Only the value of x, so there it is, just 10. Example 3, little tough, let's read this one. Each angle of a regular polygon measures 135 degrees. Find the number of sides and name the polygon. We don't know, we know the polygon's regular, but we don't know how many sides it has. So when we go to find the sum, we know it's going to be 180 times n minus 2, but we don't know the n. That's what we're trying to find this time. But we do know that once we have that sum, and we divide it by the number of angles, and the number of angles is going to be the number of sides, right? We end up getting 135. Let's try and guess and check on this one here. Use what you have though in example 2. When we had a hexagon, each angle was 120 degrees. And this angle here is 135, so is it going to be more or less than a hexagon? Probably more. Let's try a heptagon or an octagon. Start with whichever one you like. I'm going to try a heptagon. If I had a regular heptagon, my sum would be 7 minus 2 times 180, or 5 times 180, which would be 900, right? So if I had 7 angles and each one was x, if I divide 900 by 7, I would see that each angle is, this one's going to come out to be a decimal, 128.57 about. Is that 135? No, but we are getting closer. Try octagons. A regular octagon would have 8 angles, so it's going to be 8x equals something. And that something is going to come from our sum. Our sum is going to be 8 minus 2, or 6 times 180, which is going to be 1,080. So when we divide 1,080 by 8, because there's 8 angles in this figure, what does x come out to equal? Here x comes out to equal 135. That's what I wanted. So a regular polygon with a measure of 135 at each angle, find the number of sides and name the polygon. It would be an octagon, and it said find the number of sides, so there would be 8 sides. There's one more little part to this note, so there's going to be a second video. Go on to that next one.